Okay, so just in case anyone was confused or want a review video on, this is number 3 of the InThinking video. I saw some few people were confused, so I'll try to break it down. A so it gives us a block at rest on an inclined plane is shown. Calculate the component of the gravitational force acting parallel to the slope. Now, the confusing part here is that we're on an inclined plane. There's an angle here, right? And so the first thing that I said, I think I said this to Ishan, was to quite literally look at it from a different angle. See, right? See here, if we draw the block and the forces acting on it, or which would be the force of gravity, we've got this just this gravitational force vector here. This is like 100 newtons, right? However, because there is an angle, what we consider vertical and horizontal is shifted. Instead of being on this flat line here, it's on this more curved, or not curved, it's at a slant now. So our idea of direction has changed. And the best way to counteract that is, once you draw your force diagram, is to literally rotate the picture. Um, See here, I will rotate this so that my axes look vertical and horizontal. And there we go, we've got our block. And now we will shift everything by give it by 30 degrees. So our gravity vector will now be here, and a new force diagram will look something like this. And so once we have that, to find our component our components, we will resolve this. We will resolve our vector here into vertical and horizontal components. See here, break it into a horizontal and a vertical vector. So, well, I'll just label this WY. W is a shorthand for weight, and WX, our horizontal component. And it wants us to calculate the component parallel to the slope, so we will be looking for the horizontal, or our x component here, and setting up a new diagram to put everything, or to form a right triangle with our vectors. We will get something like this, where our weight vector is the hypotenuse, our vertical and horizontal uh, vectors will be our legs. Okay, and over here, we will be calculating our angle from right here, which will be 30 degrees. And from here on out, calculating the horizontal component is just a matter of trigonometry, right? So remember SOHCAHTOA, we're going to be looking at the opposite leg. So SOHCAHTOA, sine theta is equal to opposite over hypotenuse, or in other words, horizontal over our weight, our total weight vector. And substituting theta for 30 degrees, we get sine of 30 degrees equals this. Multiply by our gravitational force, or weight. We get W, or weight, times sine of 30 degrees equals our horizontal gravitational force, or the component parallel to the slope. After that, all it takes is a matter of substituting our values in, and we get a grand total of 50 newtons. I hope this helped.